Hi students, my name is Maria Pinizzotto and I am a 5th grade teacher at Crescent Elementary School in Voorhees, New Jersey. Since we're going to be together a little while this morning, I figured I'd give you a little bit of background about myself. I've been a 5th grade teacher for the past 9 years, and a little fun fact about me is that my first year teaching 5th grade, I got an opportunity to teach with my 5th grade teacher. I just thought that that was the coolest thing, and I am happy to be teaching in the district in which I grew up in. A few more fun facts about me are that when I'm not in school, I love dancing. I've been dancing all my life since the age of 3. I love working out and going to the gym, and I also enjoy competing in fitness competitions, which I've been doing for the past couple of years. I just enjoy staying active and being healthy. My favorite subject to teach is math, so today I will be spending time teaching you how to make line plots and to also solve problems using those line plots. So today we have 2 objectives to accomplish. The first one is I will be able to make line plots. Let me hear you say that. I will be able to make line plots. Very good. One more time. I will be able to make line plots. Excellent job. Okay, the second objective that we're working with today is I will be able to solve problems using fractions and line plots. Let me hear you say that. I will be able to solve problems using fractions and line plots. One more time. I will be able to solve problems using fractions and line plots. Excellent job. So before we get started with our lesson, I have a math riddle for you. Are you ready? Okay, here we go. An apple is 40 cents. A banana is 60 cents. And a grapefruit is 80 cents. I want to know, how much is a pear? Think about that while we're working, and I'll share the answer with you at the end of the lesson. Good luck! Vocabulary is very important in math. If we don't understand the vocabulary terms being used, then we're probably not going to understand the question that they're asking us. So before we begin our lesson today, I have some vocabulary terms that I want to introduce you to. The first one is data. Data is basically a set of collected information. A term that is related to data is the word frequency table. A frequency table is a display that shows how many times the data occurred. The next vocabulary term that we will be working with is line plots. Line plots and frequency tables are very closely associated. Let's think about the first term, frequency table. Frequent, how often something occurs. The line plot is then used to show how many times numbers, items, anything occurred in the frequency table. We use X's or dots to show the amount of times something occurred. Let's get ourselves ready to learn, okay? You may choose to sit in your chair for this, or you may stand up, whatever you like. Let's take a big deep breath in, raise our arms up, and exhale. Get that oxygen going to the brain. One more time, deep breath in. And exhale. Very good. Let's wiggle your fingers some. Okay, get them ready to do some writing. Okay, shake out your hands a little bit. Feel nice and relaxed, ready to go. Before we begin, you're going to need a couple things to participate in today's lesson. You're gonna need a pencil, an eraser, and some scrap paper. So I'll give you a second to go ahead and get those things. See you in a minute. I don't know about you, but I love having a snack. That's why today we are going to be using a common household cereal like Fruit Loops to introduce the idea of frequency tables and line plots. The first thing I have done was measured out a 1/3 cup of Fruit Loops. From there, I will place them on the table and separate them into categories based on their color. Once I have placed the cereal pieces into their color category, I can then determine how many times each color appeared in my snack by using tally marks. Using the tally marks, I can determine how frequently or how often a color of cereal occurred in my snack. I can then use the information from the frequency table to construct a line plot. In order to create a line plot, you need to do a couple of things. The first step is to create a horizontal line, meaning left to right, like you're looking out into the horizon. The next thing that we need to do is label that horizontal line with what we are measuring. In this particular instance, we are measuring the number of times a certain color appeared in our snack. Lastly, don't forget to label your line plot. It's very important. We need to know what we're talking about. For our particular line plot, we are going to call it Fruit Loop colors. Line plots help us view data quickly. In constructing my line plot, I was able to determine that the color that appeared most frequently was orange. I could also determine that the color that appeared least frequently was blue. Now that you have an understanding of frequency tables and line plots, let's take it one step further. We just got done working with whole numbers with frequency tables and line plots. Now we're going to take it one step further and apply that same strategy but using fractions. Okay, take a look up here. You can read the problem with me. Jacob and his father measured the lengths of scrap wood in their yard. What I did that you see here on the board is take information from a frequency table about the lengths of each of the pieces of wood that they have in their yard. Every time I saw that measurement occur, I put an X. Okay? So as you can see, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 pieces of data that I had to put on the line plot. Let's read the question. What is the difference of the shortest and longest pieces? Vocabulary word here, difference. Remember that means to do what? That's right, subtract, okay? Difference means to subtract. So we need to find the difference or subtract the longest piece from the shortest piece, okay? Now, you might be tempted to say that the shortest piece is 4, right? No, be careful with these types of questions. The least piece that is represented in the line plot, that's what we're looking for. So the longest piece is 5, and the shortest piece is 4 1/8. Do you see that? Okay. So I have the subtraction problem set up over here. 5 minus 4 1/8. You're probably saying, Miss Pinizzotto, I can't do this. I can't do this. How can I take something from nothing? Don't worry, I will show you. It's a little bit of a review. Don't worry, Miss Pinizzotto is here to help you. Don't get nervous. I know once we start seeing fractions, we become like deer in headlights. Don't do that, okay? I'm here to help you. You got this. Okay, so we know that we can't take something from nothing, okay? So we have to do a little bit of borrowing here. So I have to borrow from my 5, my whole number. I'm gonna take 1 from my 5. If I take 1 from my 5, that becomes a 4. Very good. So I'm gonna write 4. And I have to give what I borrowed back, okay? I have to give 1 whole back. But I have to do that in terms of a fraction, okay? I have to give it back in eighths. Okay, so how do I give 1 whole back in eighths? Very good again, 8/8. So now I'm ready to subtract. 8/8 minus 1/8 is 7/8. And I don't have to do anything with my whole numbers because 4 minus 4 is 0. I don't need to do anything there. The last thing I need to make sure I do is label. 7/8 of an inch. Nice work. So now we're gonna take it one step further. We're gonna do a little bit more practice. This time we're looking at amount of salt, okay? And you'll notice I took information again from a frequency table and drew the information onto a line plot, okay? you can see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 pieces of data to work with, okay? What you'll also notice is that I have grams measured from 1 all the way to 7, okay? You'll also notice this time that not all of my points are labeled, and we have to do some figuring out of what those measurements are, okay? So first things first, I have 1, 2, 3, 4, 5, 6, 7 dots, but notice this is not marked, okay? So I have to think to myself, what's between 1 and 2 on a number line? Very good, 1.5. So to show this, I would do, again, 1, 2, 3, 4, 5, 6, 7. 7 times 1.5, because that's my measurement. Okay, so we're gonna be looking for the total amount of grams that this person had in their diet, okay? Let's take a look at the next set of data. 2 spots at 4. So to represent this, I would say 2 times 4 plus, okay, again, I'm with another set of data that is unknown. What is in between 6 and 7? 6.5, very good. So I have 3 dots at 6.5. 3 times 6.5. Okay, my last set of data is over here at the number 7. 1, 2, 3, 4, 5. I have 5 dots at 7. So 5 times 7. Now all we have to do is solve. So we have our equation for finding the total amount of grams of salt. So now we have to take it one step further because we can't compute it how it is right now. We see something called does anybody know what this is an example of? 1 1/2? Very good, it's a mixed number, okay? It's when you have a whole number and a fraction. Okay, so we can't multiply a whole number and a mixed number how it is. So we have to do one important step before we do that, and that's going to apply to all of our mixed numbers that we have here. We have to do something called MAC. Go ahead, say it. MAC, very good. That stands for multiply, add, and keep, okay? Multiply, add, keep. So I'll show you what that means when I apply it to the first set of parentheses, okay? Let's take a look. So I'm gonna start with my 7, and here where is MAC comes in. Multiply, 1 times 2, your whole number times your denominator. 1 times 2 is 2. Add your numerator. Your numerator is 1. Okay, so 1 times 2 is 2, plus 1 is 3, and keep your denominator of 2. There you go, excellent, good job. On to the next one. We don't have to do MAC this time around. We have 2 whole numbers to work with. 2 times 4. So 2 times 4 is 8. Very good. We do have to MAC here. Okay, so let's write our 3 first. 3 times. Okay, let's MAC. Whole number times your denominator. 6 times 2 is 12. Add your numerator, which is 13, and keep your denominator of 2. Nice work. On to the last set of parentheses. We don't need to MAC here. 2 whole numbers. 7 times 5 is 35. And I like to use the variable. That's what this is called. Here's a little reminder. variable of G to stand for my grams of salt, okay? Let's move to the next line. Now we're gonna actually work with multiplying our improper fractions to our whole numbers and solving. So here we go. Multiply straight across. Okay, if you want to put your whole number over 1, you can do that. You don't have to, but if it makes you feel more comfortable, you can. I like to do it, so it's up to you. So 7 times 3 is 21, and 1 times 2 is 2. Okay, let's move on. We're going to add 8. Good. Now we're gonna do the same thing that we did over here in the first set of parentheses. Multiply straight across. 13 times 3. If you need to use your scrap paper, please do it. I always have tons of scrap paper by my side when I am computing. Okay, so 13 times 3, 3 times 3 is 9, and 3 times 1 is 3. So 39 over 2. Plus my last whole number here, 35, okay? Now what I can do is combine like terms, okay? Remember, like terms are examples like this. They both have a denominator of 2, so I can go ahead and just add the numerators together. So 21 plus 39, I could do it over here. I always like to write things down because then you chance getting it correct when you see what you're doing. 9 plus 1 is 10. 3 plus 2 is 5, plus 1 is 6. Okay, so I have 60 is my numerator over my denominator of 2. And when I'm done with something, I just kind of like to scratch it out so I'm not tempted to go back and use it again. So I added these two together. Now I'm done with them. Okay, let's go on to my whole numbers. 8 plus 35. Again, you can come to the side of your scrap paper. 35 plus 8. 8 plus 5 is 13. Carry my 1, 43. Okay, so I added my two whole numbers together and I can go ahead and get rid of those. Now I'm left with the bottom line, okay? We know that fractions really mean numerator divided by a denominator. So if I was to read this, this really means 60 divided by 2, okay? And so here's how you do that. You can do this in your head. Okay. I know I've been saying, write this down, but this is something that you can do in your head. Look for your basic fact, okay? Your basic fact here is ignore the 0. 6 divided by 2. Well, what's 6 divided by 2? 3, very good. And I'm gonna use a fancy schmancy term here. We have to bring back that 0. And that fancy term to bring something back is annex. Okay, go ahead and say that. Annex, very good. So 60 divided by 2 is 30. And I just have to add my other whole number of 43. So 30 plus 43 is 73, and always label. Grams. So our answer to that problem is 73 grams. Nice work. Let's do some more practice with line plots. So you'll notice I have a line plot that is labeled total amount of rainfall. You'll also notice that it is labeled with inches, okay? I want to talk a little bit about this line plot because you see fractions, okay? And fractions can be tricky, of course. But I wanted to address why you see eighths, fourths, halves throughout the number line, okay? So first things first, the number line from 0 to 1 is divided into eighths. So the first point would be 1/8, okay? If I were to continue in that way, the second point would be 2/8, right? Well, what do I know about 2/8? Yep, I can reduce it by dividing 2 over 2 and making it 1/4. Okay, if I took the next spot, that's 3/8. Perfect. The next spot over is 4/8. What do I know about 4/8? Right again, that can be reduced to 1/2. Okay, and so on. The pattern continues. 5/8, 6/8 can be reduced to 3/4, 7/8, and then I'm eventually at the whole, 1/2. I continue the pattern. 1 1/8 and 1 2/8. But again, what do I know about 2/8? Well, that can be reduced to 1/4. I also want to take this opportunity to have you think about that vocabulary word that we learned at the beginning of this lesson, okay? Do you remember that word outlier? Okay, remember the word outlier. Okay, an outlier is something that is very different from the rest of the data. Okay, notice how so far all of our dots or data are down on this end of the number line or the line plot. The outlier in this particular set of data is 1 1/4. It's not near the rest of them. Okay, so I wanted to take that opportunity to address the word outlier because this is a perfect example of one. Okay, so now what we're going to do is we are going to solve for the total amount of rainfall. Okay, so we're going to have to do some adding of fractions here. Don't get worried. We can do this, okay? So, first things first, I have 1, 2, 3, 4, 4 dots at 0. I don't really need to put this into my equation, but I'll write it anyway, okay? 0, and there's 4 dots. Good. Add, same thing, we know how to do this, right? 1, 2, 3, 4, 5. There's 5 dots at 1/8. So that becomes 5 times 1/8. Plus, we only have 1 dot at 1/4. Plus, let's keep going, 2 dots at 3/8. So 2 times 3/8 plus 1 dot at 1/2 plus, don't forget our outlier, right? Over here, 1 dot at 1 1/4. 1 1/4. Okay, and I'm going to call this R to stand for the amount of rainfall, okay? So now I can go ahead and start solving further, okay? So I know 0 times 4 is 0. I don't have to add that in. 0 plus anything will be not adding anything. So now we're gonna go ahead and multiply straight across. 5 times 1 is 5, right? And remember, you can put your whole number over 1. 5 times 1 is 5. And 1 times 8 is 8. Plus my 1/4. Plus, multiply straight across, whole number over 1. 2 times 3 is 6. Very good. 1 times 8 is 8. Plus my 1/2. Plus 1 1/4. Equals R. So since we've had some practice with this, I'm gonna give you a couple of minutes to see if you can figure out what our answer is to this problem, and then we'll share it together, okay? Good job. So this is our problem that we just dealt with, and I asked you to go ahead and take a few minutes to see if you could solve the problem. So hopefully you have the right answer, and we're gonna check it together right now, okay? So the first thing that I hope you did was to combine like terms. Remember, we talked about that earlier in our lesson, right? So I have 2 fractions whose denominator is the same, okay? 6/8 and 5/8. I can combine those two together, okay? So 5/8 plus 6/8 is 11/8. So I'm gonna write that down. And again, when I'm done with things, I just like to cross them out, just so I know that I've done them, okay? And then you can go ahead and rewrite the rest of the problem. Plus 1/4 plus 1/2 plus 1 1/4. And we're solving for R for rainfall, okay? So now I can go ahead and combine more like terms. I see 4 in the denominators, okay? So I'm gonna take my 1/4 and add it to 1 1/4. Well, 1/4 plus 1/4 is 2/4. What do I know about 2/4? That equals 1/2. So 1 and 1 1/4 plus 1/4 is equal to 1 1/2. So I'm gonna go ahead and write this. 11/8 plus what I just added, 1 1/2. Okay, so I'm gonna get rid of that and get rid of that, plus my half here. I'm in luck. I've got more like terms, okay? So now I've got 1 1/2 plus 1/2. Well, what's 1 1/2 plus 1/2? 2, very good. So now I'm gonna go ahead and rewrite 11/8 plus 2 equals R. So I've got one last challenge to get through before I find the sum of rainfall. I have to change this improper fraction into a mixed number, okay? I can't add these two things together how they are. So remember, in order to find a mixed number, you have to do some division. This means 11 divided by 8. Okay, so off to the side here, you can do 11 divided by 8. 8 is your divisor and 11 is your dividend, okay? So let's do some division. 8 does not go into 1. I like to put a little bit of a X over that place value. 8 does go into 11 one time. Okay, and my difference is 3. So I use my difference as my numerator and my divisor becomes my denominator. So 11/8 as a mixed number is 1 3/8 plus, now all you have to do is tack on that whole number 2 equals R. Okay. Last step, we're almost there. Add your whole numbers. 1 plus 2 is 3, and tack on that fraction of 3/8. Okay, so remember again to label, label, label. Remember our data was labeled in inches, okay? So we have to label our answer in inches. So the answer to this problem, hopefully you got it correct, is 3 3/8. Okay, nice work. I bet by now you are becoming math experts at line plots. Okay, let's keep going. The old saying, practice makes perfect, right? Good. Actually, practice makes progress. I like that better. Okay, so here we go. We have a line plot with amount of flour, and you notice that the flour is being measured in cups, okay? Again, this number line looks a little different than the other ones, right? Because as we discussed before, our denominators are different. But remember, I already told you from the last exercise that if you were to break this into eighths, because that's what this number line is broken into, you know that the first hash mark is 1/8, the next one is 2/8, but that can be reduced to 1/4, and so on. 3/8, 4/8, a half, all the way up until you get to 1. Okay, so that's just a little reminder, because I know, like I said, fractions can be tricky and it's always nice to have a little reminder. Okay, So we're looking for the total amount of flour. So here we go, okay? 1, 2, 3, 4, 5. 5 dots at 1/4. So 5 times 1/4 plus 1, 2, 3, 4. 4 dots at 3/8. 4 times 3/8 plus 1, 2, 3, 4, 5, 6, 7 dots at 1/2. So 7 times 1/2 plus 1, 2, 3, 3 dots at 3/4. So 3 times 3/4 plus 2 dots at 1. So 2 times 1 is 2. Okay, I'm gonna go one step further. Here we go. Remember, to multiply a whole number times a fraction, we have to put the whole number over 1 and then multiply straight across. Here we go. Put 5 over 1. 5 times 1 is 5. 1 times 4 is 4. Plus 4 times 3 is 12. Good. 1 times 8 is 8. Nice work. 7 times 1, straight across. Let me hear you. 7, very good. 1 times 2 is 2. Excellent. Almost done. Straight across. 3 times 3 is 9. Good. 1 times 4 is 4. Excellent job. And now we just have to tack on the whole number of 2. And remember, I need my variable, right? You can choose any letter that you like. I'm gonna use F for flour. Okay, so I'm gonna give you a minute. Make sure that yours matches mine. Okay, remember to do your division, dividing your numerator by your denominator, adding like terms, and seeing what you get for your sum for F. I'll give you a couple minutes to work that problem out. Okay, so when we last were talking, this was the equation that you should have had set up in your scrap paper or your notebook. By the way, if you're running out of scrap paper, because we've been doing a tremendous amount of work and I'm so proud of you for that, if you need to get some more scrap paper, now might be the time to do it, okay? All right, so let's take a look. As before, I told you to remember to combine like terms. So we have 2 fractions that we can start off with that have the same denominator. Yep, I'm looking at 4, right? So I can go ahead and add 5/4 plus 9/4. Okay, so 5 plus 9 is 14 over 4. And again, like I've told you, I like to go ahead and cross them out when I'm done with them. Okay. And then I can go ahead and write the rest of the equation. Equals F. Okay, so now I can combine more like terms. Okay, I've got a 4, an 8, and a 2. All right, so let's kind of work this together. I can make 2 have a common denominator of 4, right? If I multiply 2 times 2, that gives me 4. Okay, so remember, whatever I do to the bottom, I also have to do to the top. So 2 times 2 is 4, so 7 times 2 is 14. Okay, and you can go ahead and rewrite. Plus my whole number of 2. Okay, now since I have like terms here, right, I can add my numerators together. 14 plus 14 is 28. Very good. So I have 28 over 4 plus 12/8, right? plus 2 equals F for my flour. We're getting there, okay? I also know that I can make 4 have a common denominator of 8, again, by multiplying by 2. Okay, so if I work over here, 4 times 2 is 8, so 28 times 2, and if you need to do your work over here, remember, just do it off to the side. 8 times 2 is 16, carry my 1, is 56. Okay, so this becomes 56 eighths. So I can go ahead and cross this off, add my 12, right? Equals F. Okay, so now I'm almost there. Okay, I have 8 and 8 as my denominators, so I'm just gonna have to add my numerators together. Okay, 6 plus 2 is 8, and 5 plus 1 is 6. So I have 68 over 8 plus 2 equals F. We're almost there. So I needed some more room, so I needed to get more scrap paper or erase my whiteboard so we could do more work, okay? So we left off at 68 over 8 divided plus 2, excuse me, equals F for flour. Okay, so I know now I'm almost there. This means 68 divided by 8. Okay, so we're gonna do our work off to our side. 68 divided by 8. Okay, remember our 68 is our dividend and our 8 is our divisor. Okay, we're looking for our, anybody remember what the answer to a division problem is? Yes, quotient, very good. The answer to a division problem is quotient. So here we go. 8 does not go into 6, so I'm gonna put an X over there to save my place value. 8 does go into 68. How many times without going over? Let's think to ourselves. Yep, 8. Okay, so 8 times 8 is 64. And I'm left with 4, my difference. Remember, my difference becomes my numerator, right? 4, and my divisor becomes my denominator. Good. So my quotient, remember, is 8 and 4/8. Well, what do I know about 4/8? Let's do some simplifying. 4/8 is equal to 1/2. Very good. So let's go ahead and add that to the rest of our equation. So we have 8 and 1/2 plus our whole number of 2. Okay, here we go. Add our whole numbers. 8 plus 2 is 10, and tack on your half. Remember what we were measuring? Cups, right? Cups of flour. So remember to label. So your answer here to the sum of flour is 10.5 cups. Hopefully you got that right. I'm sure you did. I'm hoping you're gaining some confidence. You are doing a great job. Keep it up. So you have been working so hard up until this point, and it's about time to take a little bit of a break. Wouldn't you say? Okay. So what I thought I would do is read a couple of pages from a story titled Math Curse. Okay, so find a good spot, on the floor, on your couch, wherever, blanket, get cozy, okay, and relax, sit back, and enjoy. Okay, so Math Curse. On Monday in math class, Mrs. Fibonacci says, you can think of almost everything as a math problem. On Tuesday, I start having problems. I wake up at 7:15. It takes me 10 minutes to get dressed, 15 minutes to eat my breakfast, and 1 minute to brush my teeth. Suddenly, it's a problem. 1, if my bus leaves at 8 a.m., will I make it on time? 2, How many minutes in 1 hour? 3. How many teeth in one mouth? I look in my closet and the problems get worse. I have 1 white shirt, 3 blue shirts, 3 striped shirts, and that 1 ugly gray plaid shirt my Uncle Zeno sent me. 1. How many shirts is that altogether? 2. How many shirts would I have if I threw away that awful plaid shirt? 3. When will Uncle Zeno quit sending me such ugly shirts? I'm getting a little worried. Everything seems to be a problem. I take the milk out for my cereal and wonder, how many quarts in a gallon? How many pints in a quart? How many inches in a foot? How many feet in a yard? How many yards in a neighborhood? How many inches in a pint? How many feet in my shoes? I don't even bother to take out the cereal. I don't want to know how many flakes is in a bowl. Mrs. Fibonacci has obviously put a math curse on me. Everything I look at or think about is becoming a math problem. I try to get on the bus without thinking about anything, but there are 5 kids already on the bus. 5 kids get on at my stop, 5 more get on at the next stop, and 5 more get on at the last stop. True or false? What is the bus driver's name? Mrs. Fibonacci has this chart of what month everyone's birthday is in. Which month has the most birthdays? Which month has the fewest? Why doesn't February have a W? Don't you think this chart looks sort of like a row of buildings? Do you ever look at clouds and think they look like something else? What does this ink blot look like to you? Lots of shapes still, right? Numbers everywhere. The whole morning is one problem after another. There are 24 kids in my class. I just know someone is going to bring in cupcakes to share. We sit in 4 rows with 6 desks in each row. What if Mrs. Fibonacci rearranges the desks to make 6 rows? 8 rows? 3 rows? 2 rows? I count the 24 kids in our class again, this time by 2s. Jake scratches his paper with 1 finger. How many fingers are in our class? Casey pulls Eric's ear. How many ears are in our class? The new girl, Kelly, sticks her tongue out at me. How many tongues are in our class? I'm about to really lose it when the lunch bell rings. Unfortunately for me, lunch is pizza and apple pie. Each pizza is cut into 8 equal slices. Each pie is cut into 6 equal slices. And you know what that means? Fractions. 1. If I want 2 slices of pizza, should I ask for A, 1/8, B, 2/8, or C, 2 slices of pizza? 2. What is another way to say a half of an apple pie? A, 2/6, B, 3/6, or C, very long and in French. And number 3, which tastes greater? A half a pizza, or B, a half an apple pie? We haven't studied fractions yet, so I take 12 carrot sticks, 3 at a time, and eat them 2 at a time. In the afternoon, every subject is a problem. Social studies is a geography problem. The Mississippi River is about 4,000 kilometers long. An M&M is about 1 centimeter long. There are 100 centimeters in a meter and 1,000 meters in a kilometer. Estimate how many M&Ms it would take to measure the length of the Mississippi River. Estimate how many M&Ms you would eat if you had to measure the Mississippi River with M&Ms. Bonus, can you spell Mississippi without any M&Ms? Okay, so I hope you enjoyed this story, or part of this story anyway. You can always read more whenever you have some time. Okay, I hope you enjoyed this section of the story Math Curse. Let's get back to work. You have worked so hard, and I am so proud of you, and I know that I feel accomplished, so I hope that you are feeling accomplished too. We're gonna do one last practice problem today, okay? Just to make sure that we have our understanding of line plots, okay? So here we go, last problem. Okay, remember that a line plot has a couple of things, right? Just as a review, it has a title. In this particular case, it is called Time Spent Practicing. It can be time practicing whatever it is that you like. I know many of you out there probably play sports or maybe perhaps an instrument, so you can apply this to maybe the time that you spent playing the violin. Okay, let's go with that. So we have different sets of data from 1/4 to 1 1/2. Okay, so we're gonna go ahead and we're gonna start writing our equation and figure out how much time we spent practicing the violin or whatever that you have in your mind, practicing soccer, basketball, whatever. Okay, so we have 3 dots at 1/2. So remember, 3 times 1/2 plus 1, 2, 3, 4, 5, 6. 6 days spent practicing 3/4 of an hour plus 1, 2, 3 plus 1 1/4 plus 1 1/2. Okay, so we have to do a combination of skills. Remember to multiply a whole number times a fraction. We multiply straight across, right? Put our whole number over 1. Multiply straight across. 3 times 1 is 3. 1 times 2 is 2. Plus, multiply straight across. 6 times 3 is 18. 1 times 4 is 4. Add your 3 plus 1 1/4 plus 1 1/2. Equals, let's say, P for practicing. Okay, so we have this ready to go and to solve and to have like terms, so let's take a look at the next step. Okay, so we left off, I gave you a couple of minutes to try and decide what the answer is for this particular question. So we're gonna take a look at 2 sets of like terms, okay? In my mind, I'm picturing 2 sets of like terms. I'm gonna tackle this one first. Okay, I can make common denominators using 4. Okay, so I'm gonna stick with my 18/4. And I'm going to change my 3/2 into an equivalent fraction using 4ths. So 2 times 2 is 4, so 3 times 2 is 6. Okay? That's one set. Now I can take this set, they have mixed numbers, okay? But I'm really just focusing on the fractions here. I know that I can make an equivalent fraction using 4. Okay, so 4 would be my denominator. So I'm going to go ahead and rewrite the rest of my problem. But I'm going to rename 1 1/2 using 4ths. So I know that that becomes 2 times 2 is 4. So 1 times 2 is 2. Okay, so now I have a bunch of like terms. Okay, so I'm going to take a look and I'm going to go ahead and add my fractions that I started with over here. 18 plus 6 is 24 over 4. And rewrite the rest, plus 3 plus, now I can combine these terms here now that they are the same. They have the same denominator. So 1/4 plus 2/4 is 3/4. And my whole numbers, 1 plus 1 is 2. So 2 3/4. Everybody with me so far? All right, we're almost there. So, last step. Remember that I said earlier in the lesson that fractions really mean division, right? So this really is saying 24 divided by 4. Okay, and we know that 24 divided by 4 is 6. Very good. 6, and then rewrite the rest of the problem. Okay. Now all I have to do is add my whole numbers together and tack on my fraction. So 6 plus 3 is 9. 9 plus 2 is 11. And tack on my 3/4. Remember to label, right? Remember we were working with hours. Okay, so the answer to this problem is 11 3/4 hours. Students out there, I am so proud of you for working so hard today. You've accomplished a lot and you should be proud of yourself for sure. Keep up the great work. Do you remember that riddle question I asked you at the beginning of the lesson? How much is a pear? Well, if you guessed 40 cents, you are correct. How I got 40 cents was that each vowel in the word pear is 20 cents. E and A are both worth 20 cents for a total of 40 cents. Nice job. Okay, math students, we are at the end of our lesson. I, for one, am so happy that you are participating with me and interacting with my lesson. I am so proud of you, and I know that your teachers at your school are proud of you as well. Just a little reminder to stay sharp, stay safe, and to stay strong, okay? Nice job this morning. Enjoy the rest of your day.